it individually. You can see report, although your answer will be totally similar with your friend, right? Because you are doing together. But please submit it individually, because I already mentioned why. Don't depend on others. Maybe you say, okay, I already sent to my team member, I already sent to my leader, but who knows, maybe your members or team leader having a problem. They said they already sent, but suddenly they didn't send, so that will be a problem also. Later on you will fight it to each other, then your mark is 0. Who want to be blamed, you or your friend? That I guess, before you blame your friend, you are the one can blame yourself, because why don't you just simply take your 3 minutes to just go to your e-learning and upload? So that is why I ask you to submit individually. And for lab 1, I guess a lot of you submit very, very late until the test 1. I guess so. Still, there is students said, I don't have enough time. I think all of us are having 24 hours per day, similar. I don't know whether you are prime minister, maybe very busy, cannot handle that simple lab 1. So think about that. If you cannot manage your time well, so do you think that you are a good person? Too many complaint. That's maybe too many time on complaint. So here, while you are writing your name here, please make sure you write maybe on this empty side your group member, or maybe here at the empty side here your group member name. And your section, please don't forget your section. That is important. Although you don't remember my name is okay, because I'm not that kind of person that want my student to remember me. But your section is important. And what else? Okay, but for the video, you can see here I put all member, which is not all member. Means that one video for all member, means that one group, one video. No, but in this video I want all member to participate. Maybe I give you very flexible. As I mentioned, I can help you as long as you show me your effort, that you do it very well, you do it at least. Don't give me a complaint but you didn't do anything. So if you said like, okay doctor, I have problem with this, I done or I already tried to do but you cannot, so that is excuse that I always like, okay lah, I can accept. Last time also in lab 1, I give you the flexibility to choose any question. So I'm not very critical in giving mark, or maybe give you any like specific things to do, or maybe I give you all the question to submit, especially for the video. Same to your lab 2. It is very flexible. You can pick any question, but you need to separate it to like maybe 3 or 4, right, in your groups. So maybe you want to explain question 1, but I don't think that it is necessary for all 4 students to explain all in this, because this is just a drawing. So maybe one person are explaining on the drawing part, which is maybe you create a simple video how to create this drawing in the Deed Simulator, and then second student doing the question 2, third student are doing question number 3, and maybe question number 3 2 student. So it is depend on you. You discuss with your group member how you want to distribute the task. So how many question also is depend on you. I don't specific. Maybe you need to do all, or maybe you want to specific only part B, or maybe part A. Okay, as long as you do the video. And the presentation video, you need to open your your webcam. Last time for lab 2, I am okay with that because it is individual and because that is the first lab for you. But experience from last semester, some of you are just taking the video from others. So that's why I want you to present it, open your webcam so I can see who are presenting. So all the team member need to be present. Maybe it is very hard for you maybe to create like one session Google Meet together to present. So you can separate like one of your friend doing and record by himself or herself for question number 1, and then you do it for question number 2, then you combine the video together. I don't want you to submit separate video, okay? So one video with the combinations of all member presenting. Any question about the lab? Okay. Next, if there is no question, in your lab 2, you need to finish the module 5 first. If you did not go through your module 5, if you did not finish yet your group 5, you cannot answer, especially for part B. Can you let me in? There's someone. Okay. Back to here. Okay. In your lab 2, in the module 5, there is new things that you're going to see, especially on dual symbol. That is new things, and in the module 2, in the module 5, and then there is circuit, Nand dual symbol, and for this part B, it is totally from your module 5, which is on scenario basis or problem based. So you are the one need to know how many input that are available, how many output, how the truth tables look like from the scenario given. Part B. And then experimental setup. Okay, for this part, you can see here, although maybe you don't want to make this as a video, but you need to submit it PDF. Then you need to like add on another pages, right? Especially for the did simulator drawing for the circuit, and then the care maps, the truth table. So you need to have extra pages. You draw it by yourself. It is depend on you whether for your answer you want to typing using your computer, or maybe you want to just use your handwriting also can. Okay, I'm very flexible with that. So although like normally sometimes you say you don't know the answer correct or not, it's okay for me as long as I can see you do. Normally I will give you full mark, although like sometimes your answer is wrong, but I will give you nearly to full mark, but follow exactly what I said. Maybe I said, okay, I give you 1 week, so I hope that you submit on time. Don't delay until last time. There is a few students give excuse, very busy in weekends. I don't know what's weekend you are doing. And then until after test 1, okay, I said, I give you until test 1, after test 1, and then I give you until midnight. Also cannot. I don't know what happened. I give you several hours, but too many delays, so I don't want that happen anymore. And I don't think that you are a good student if you are keep delaying things. Okay, for your lab 2 here, part A. First question, you need to use your did simulator, and then you can see here you need to construct a truth table. If you cannot manage to write here everything, you can use your other paper. draw back the truth table and then put the input and output value. And in our module 5, you will going to learn on dual symbol. So you need to draw the dual symbol. So by today, we're going to do recap for module 5. What is dual symbol? What is AND or logic? AND or not inverse logic? What is NAND? Circuit? What is exclusive circuit, and etc. So if you have any question related to the lab, maybe you can't to understand like situation here, or the question asks what, so you can PM me personally, okay? Don't request for me to change your group member if you can still discuss and what we can say, passion, bersabar, or tolerate with each other. Last time I need to change because they already found in my Google Classroom, so I said okay lah. So one person, lastly, the one student need to do it by himself. So yeah, all the group member don't want him in the group. So maybe you can say that in your future, maybe in your work company, they fired you. So you can see the situation there. Although in a small group you cannot manage, how about a small, your big company later on? Okay, let's proceed to our module. Our module 5.
Doctor, in
Yes.
the lab exercise, you said you told us to paste the circuit. Can we just like screenshot deeds, the circuit in deeds, and paste
Yes.
that?
Yes.
Okay.
Okay. Okay, shall we continue? Okay, in your module 5, you're going to learn on AND or logic. So last time, if you still remember, there is a SOP circuit, and then there is POS circuit also. How their circuit look like? So for AND or logic, it is basically the SOP circuit, which is you start with AND, all the AND first, and then you combine all the output to be connected to the O. So it is similar to the SOP circuit. And then after that, there is AND or inverse logic. When you inverse the SOP Boolean expression, you're going to get POS. So you need to know between each other. And you also will cover on exclusive or exclusive no, XO, XNO logic circuit. So how it's look like, exclusive circuit, we're going to look by today. So first of all, uh, okay, first of all, you can see here, there is an or logic. And or logic. And dah lupa ke? Do you forget these symbols? This is AND gate. This is OR gate. No need for me to explain one by one. So here is SOP expression when you have and and also O gate. So SOP expression. So basically, sometimes they will just mention draw your SOP expression, or maybe they said by using the SOP expression circuit below, so you know, okay, this is how look like the circuit like this. And from here, if you still remember the SOP circuit condition, you will notice that there is a, for every n input, if you have 10 n logic gates, if you have 10 gates, n gates for 10, so at least one and get the output of 1. So your output for your all circuit will be also 1 because this is O. And you're going to get F equal to 0 if only all is 0. So this is the condition. But I guess if you know like how basically the output from this side and the output for your O, then it is easy for you to get. So you can also try draw the circuit into your gate simulator and see the output combination, what will happen. And basically from this kind of circuit and this Boolean expression, it's similar to your truth table here. You can go and try to make it standard version first, standard SOP, then you can come out with your truth table here. From this truth table, you can derive the expression, which is your standard Boolean, which is you look into the output 1, output 1, output 1. After that, how you going to simplify, which is basically you want this kind of versions, which is simplify, you will map this truth table to your care map. You draw the care map. And after you draw, you go into group, and you come up with your simplification versions. And lastly, you're going to implement using AND OR logic, because this is a SOP. So it's going to be AND OR logic. We go through how we're going to get the AND OR logic circuit. So this is the truth table given. From this truth table, you can get your Boolean expression. See? You can come out. So no need for me to explain. This one is in your module 4. If you cannot manage to do it, means that you have problem in your module 4. Please go back and look back how you can come out with this. And after this, you can map it to your care maps. So you just map the value of your output here and put into your care map, and you group that. After you group, you can come out with the product term, and you will get the versions of simplification. From here, you can draw the circuit, which is you will get A, B, C, D, and and then there is the O gate here. This one A, B, C, D. So this is the simplification versions from this example. Okay, from you can see last time I mentioned you can get the simplification version using the care map, but there is a possibilities for you to be asked also in term of Boolean expression. How are you going to do this? Simplify expression using Boolean algebra. So you need to do the rules, you need to do the law, you need to use the De Morgan theorem. Otherwise, following the equations, the expression that given. So no need for me to go through one by one. This one is totally from your module 4A, isn't it? 4, yeah. I hope that you still remember the rules and also the law here. And finally, you will get the simplification versions, which is similar to the one that you do for your CAMAP. Since like CAMAP much more easier, right? Because I think I vote for CAMAPs. Maybe you kind of like doing the rules and using the law. Maybe you think that that is easy, maybe. So it's depend on the persons. So you come out with the final answer. This is using the CAMAP. You can just draw like this, and from this simplification using your rules and law, then you will get the similar things. So that is on your AND OR logic. Now you have AND OR inverse logic. Don't look directly to the POS. Let's say you don't know that AND OR inverse is for POS. You will have AND OR. If you still remember, this is SOP, which is you have AB plus AC. Example, okay? Then, if you have that inverse here, you just have inverse on top of all the equation here. So from this side, if you see this long single bar, what you're going to do? You're going to use your De Morgan theorem. So you're going to solve this long first. From here, this is positive. It's going to be a multiplication. So you're going to multiply these two. You put single bar from this long bar. So this will be AB. This will be CD. Why? Because if you still can't remember, this one is positive, it's going to be negative, it's going to be multiplication. The long bar, you're going to separate it to be here. Then you solve this part. This part is going to be multiplication. So it's changed to be a positive. Then this long bar will be separate. You will get A bar plus B bar. Then this is remain, which is multiplication, because there is no long bar anymore. Here, this bar will be changed to the positive, and the input is C and D, and this long bar for C and D will be separated. You can see here, this is what? This is POS. That's why this one, which is AND or inverse, is POS expression circuit. Okay, from here, this is how this circuit look like. You have AND gate, you have OR gate, you have NOT gate, which is the inverse. After that, you can see this is your previous and OR, and then you add another inverse. You will get the POS. Okay, this is the truth table for inverse. This is your last AND OR logic. This is an or inverse. You can see it's just inverse the output value. The truth table from this. And it is a complement of AB plus CD. From this following slide here, normally it's not going to like say, okay, this is the N or inverse, but instead it will use the term of active low output by using, then you know, okay, you are going to use that. Sometimes it's not going to give you like this, because you know already solve the problem for N active low output. So you know that it is the inverse for your and or logic. So inverse is going to be the active low using and or inverse logic. To implement an active low output, take the complement of X last time. So this is your A, B, C plus C, D output. And you're going to do the inverse. You're going to do the inverse here. So this is the inverse, which is you have the active low using the AND or inverse logic. And from here, you will be also can be asked into the derive the expression. But please make sure when you have AND or inverse logic, you keep in your mind that will be POS. So POS, what output that you're going to look? The output 0. So the output 0, you're going to look and it's going to come out for your POS, not SOP anymore. And you simplify using K-map, which is you look at the 0, 0 and you're going to group the 0 and implement the AND or inverse circuit. You draw back the circuit. Okay, let's take a look into. Okay, before that, there is a note here that you need to remember. If we want active low, put an inverse. See, if we want active low for this AB plus CD from the example slide before this, put an inverse output of the SOP circuit. This is SOP circuit. We put an inverse. It will produce the POS. So that's why I mentioned it's going to be POS. Just now you can see this is your AB plus CD, which is SOP. You're going to inverse it. Okay, kat situ juga. Okay, here it's going to be inverse. Then remember, this one will be POS. Put here, you put here, pick here, you map it to here, which is the 0, 0 part. Then what you need to do? You need to do a grouping. So that will be a groups. And you come out with your POS expression, which is sum of product. So the expression from the truth table, is standard SOP. So it's going to be long. You can see here, standard SOP. And this from the K-map is the simplified versions. So this is a simplified version. So any question for your AND or logic and AND or inverse logic? If there is no question, we can proceed. This also similar. You were given the table there. and then it asks you to do the active flow using the AND or inverse logic. So when you notice this, you know that is POS. So you pick the output of 0 there, and you did a groups. When you did the groups, you're going to come out with your Boolean expression. Okay, now we move to our universal properties of NAND and NOR gate. So you're going to have two kind of universal property, which is NAND and also NOR gate. I hope that you still remember the symbol of NAND. NAND symbol. It is look like AND gate, but there is a bubble here, which is the inverse thing. It's going to be inverse the AND gate. So this is the NAND gate. So of course my drawing is very ugly. And NOR gate, it is similar to your OR gate. And there is a bubble as a node. So this is a OR gate. So please make sure you still remember the symbol. And following this symbol, you read by yourself here, you need to come up with the several possibilities for you to be asked, especially please draw the circuit using only NAND gate. Draw the circuit by using only NOR circuit. So usually SOP going to implement NAND only, POS using NOR only. So I hope that you remember this. You can go through and read one by one. But after all, how in the real life you're going to implement this? Because you will say that I have like AND gate, NOT gate. Why don't I just use a simple basic gate rather than I want to like know the combination of NAND gate to represent what and etc. So actually, if let's say in your real case, suddenly you are lacking of NOT gate, suddenly you missing your AND gate, but you still have many NAND gate in your stock. So how you going to like construct the circuit, the real circuit, the hardware things without the NOT gate, without the AND gate, because your circuit need that. So instead of having this, you can combine your NAND gate to be represented as NOT gate. You can combine the NAND gate to be the AND gate and etc. So here, this is the thing that you need to remember, how the connection look like to represent the NOT gate. Sometimes you were given the circuit, you just need to change it to be the what we can call the not vice versa, which is the representations of NOT gate using the NAND gate. So you need to know how to draw it. And a NAND gate, which is one single NAND gate, it is represented as NOT gate with the following input to be connected to each other to be one single input. After that, you can see here, when you have two NAND gates, you can combine together and you will get the AND gate. Please try to check whether it is correct or not. I don't want to prove anymore, because you can prove by yourself, which is put this kind of connection and compare the output. Is it similar, the output with the AND gate or not? And with the 3 NAND gate, you can get the OR gate. How basically the 3 NAND gate? You need to remember the connection also. Don't like do like whatever mentions. Okay, as long as it's 3 gate, 3 NAND gate, then yeah, I have the OR gate. So how you connect to each other, it is also important. So the connection is like this, so you need to remember, and it is represent the OR gate. And lastly, for NAND gate, addition is in front the NOT gate there, you can see. Then you have the NOR gate. So instead of only NAND gate, you're going to have also representation by using NOR gate, but later on we will see. Let's go to the example. Using NAND gate, implement each expression. Okay, you can see here this is NOT gate. NOT gate, it asks you to only draw using NAND gate. So draw the NAND gate. This one is NAND gate. This is A, and this will be A bar. And you're going to have OR gate. OR gate how? You're going to have 3, right? 3 NAND gate. This one, this one will be B. Connect to NAND gate and another NAND gate. So this is the circuit for this question number A. You can see this is your OR gate here. So I can draw like this. So all the gate inside here is only NAND gate. So you can do that also similar to your question number B. Is it represent? Okay, here. Okay, from here you can see for solution number A, you have NOT and also OR gate. You draw the NOT first. This is representations of NAND gate using your NOT. And for OR gate, it is similar like this. So it's very simple. Then your answer is correct. How to do that? You need first to remember. Okay, the thing is here, there is one more things that you need to know. Okay, when you draw like this, last time when you draw like this, you're going to remember that when you have NOT and then NOT, you have A, right? Here it will be A bar and this part will be A. Means that it is nothing between here because it is basically direct. You already direct it because NOT and NOT. Similar to this circuit, you can see here. In this circuit, you have NOT gate again. So when you have two NOT, you just remove it and you connect it to be one direct line. So there is also possibilities it will become out, which is you're going to need to draw these two things, and you are the one that need to remove from your circuit to be a simplified versions. So the final answer will be like this from your A bar plus B. This is a representation using the NAND gate. Next, question number B. You have NOT gate here and AND gate. So NOT gate will be like this and gate will be like this. So from here, you cannot remove this. Cannot remove this one because you can see what is the difference between this NOT. This is direct one input. This is another one input, which means that here is A, here will be A. But at this side, this is two input. which is at this side, it will be, from here it will be A. From here it will be B. This is will be A, B bar, and this part will be A, B bar, like this. Only this part is not. This is not. This is not. This is not inverse. Okay, this is not inverse. This is NAND. This is inverse. So you can see the difference. This is NAND gate. This is not gate. Although this is NAND, although this is also NAND, but this connection make it as a NOT gate. Okay, do you understand what I mean here? Although it is a NAND gate, but the function is represented as a NOT. This one is NAND gate and still NAND gate. The function also as a NAND gate. It is not gate. That's why you cannot simplify it and remove this two other. But for this circuit, you can see this is NAND gate. This is also NAND gate. But the connection make it to be the function to be NOT. This is also NOT. When you have NOT with NOT, you can simplify and remove this. For this example, this is NAND gate. This is not function. Okay, so that's why you cannot remove this. So please be carefully check how you're going to simplify. For this is the final answer. You cannot simplify anymore. There is another one. Use NAND gate only to represent the expression. Draw first the real NAND gate or OR gate here. And from this side, you draw it one by one. You can see this is the AB for your AND gate. And you draw another AND gate below here. This is another AND gate function. Although this is all the NAND gate, but the function is AND. And you combine it and change this to be your OR gate. You can see? So this is OR gate. Now you can simplify. I write the function, okay, not the gates, because we know all this is using NAND gate. But the function here is NAND. This is not gate. This is not gate. Similar to the below part. Not and not you can remove. Don't remove this and this because this is NAND. Function NAND gate. This is not gate. You cannot remove this and make it the connection like this. Okay. So the one that you need to remove is not and not. Not and not. That's why finally you will get the answer like this. This just the G2, G4, G5 and G6, G2, G4, G5 and G6. Okay, any question for NAND gate?
No, doctor.
Okay, thank you. So I proceed for NOR gate. It is basically similar, which is similar to NAND gate. Only some part is different, which is you can see this one is similar, not gate. From the NOR is going to be not. But for two combination, last time two combination of NAND gate is going to be AND gate. Last time is AND gate. But this NOR gate, it will make it as a OR gate. You need to remember how the connection look like. After that, you can see here, if there is 3 no, it's going to be a AND gate. If it is 4 no gate, it's going to be NAND gate. Last time, if you have 3 NAND, you're going to get O gate, and 4 NAND is going to get no gate. So it vice versa, okay? As long as you remember all, I guess it's very easy for you to come out with the circuit. So from this example, you're going to get the using no gates implement for each expression. So you have O and also not and also O. From here, you draw first the representation using no gate, and this also you convert, and you cannot cancel here. This one is not function, this one is no function. That's why you cannot remove each other. So B, number B, you can see here you represent the NOT to using the O gate, and this NAND gate you represent using NO gate. Now you have here NOT function and NOT function. You can remove. So final, you will get like this. Any question? Very easy, right? So this is like a bonus mark for you because you just need to remember. After you remember, then you can simplify and very easy for you to draw. So now we have the dual symbol. For the dual symbol here, what is the meaning by dual symbol? This is dual symbol. This is dual symbol. So if you have NAND gate, the representation or the alternate symbol using the dual symbol is the negative O. What is negative O? There is a not in front the O. And for the no, the dual symbol for no gate, it is a negative N, which is you have not in front the AND gate. So this is the alternate symbol for no and alternate symbol for NAND gate. Example, okay, you can read this by yourself. Example, how and where you're going to apply. Just now I already mentioned if you have not, you can remove it. Not, you can remove it and your answer will be similar. So you can try to look this. Okay, we have this example. It asks you to convert these following SOP circuit to be NAND only. If you still remember, last time you can also represent this kind of AND gate. You're going to use 2 NAND gate, isn't it? 2 NAND gate. This one is AND gate, isn't it? So you draw the similar. CDAB. This is AND gate represented by using NAND gate and then NAND gate. Now for this O, you will have, I can't remember, I guess like this. 3 NAND gate. And it's combined with the NAND gate there. I hope it's correct. So this is the combination, and you can see later on you can remove this remove this, remove this, remove this. Finally, you will get only three NAND gate. You can see this is a final answer. This is final answer from your things representation there. But now you were given with very easy way. From here, it asks you to play around with bubble things. So from this bubble, which is dual symbol, you can easily convert when you have this kind of looks, which is bubble, which is negative, or you will get NAND gate. If you have negative N, you will get no gate. Okay, how to apply? Let me show you. We have this kind of loops or circuit. So when I want to put bubble here, I need to put bubble here also. Why? Because not and not, it doesn't give any effect. Not and not doesn't give any effect. So why don't I just put there? Because I want to change this to be NAND. If I put this bubble, it's already NAND gate. But I cannot just simply put one bubble. I need to have another one bubble to remove to make it natural. Natural, right? Not and not, which is nothing, which is natural. So I done this part. I have another one, AND gate. Why don't I put this bubble things here, this bubble thing here? Then I have my NAND gate. I want NAND gate only, see? So this is my purpose. So now I have my NAND gate. I have my NAND gate. I didn't have any worry with this. Now that is my problem because the question asked me to do NAND gate. Oh, let me check. This is a dual symbol. If I still remember, this is the negative O, and negative O is similar to NAND gate. So I can just represent this to be NAND gate. So I get, okay, put the bubble, and I will get my 3 NAND gate. See, this is what the meaning by putting the bubble thing, which is similar the one that I showed just now, step by step. Okay, so that is on applying NAND gate, which is playing around with bubble to the SOP things. Now we look into the POS, similar also. When it asks you to do only no, so you can see there is a possibility to you to put bubble in front to be a no. But of course, you need to have the natural part, which is you need to put another no and another not. I have another bubble here, so it's going to be no. So I need to put another bubble here also, similar to this part. So I don't have any worry to my these 3 no because it's already no. But I have problem with this part. When I remember back, I can see this is my dual symbol. Dual symbol for my negative AND gate similar to my OR gate. So I represent like this. Ta-da! From this circuit, I can get similar. But in terms of no gate, the output will be similar. The truth table for this part and this part will be similar. In terms of representation only, it's going to be different. But the function is similar. Okay? So that is the dual thing symbol. Any question? Before we can move to odd, even. Okay, if there is no question, let we move to our still dual symbol, but in terms of different scenario, which is you can see here, you need to know odd and even. What is odd, what is even? You need to replace, look into the output side. Okay, this is the output side, right? This is the input side. First level for your output side is going to be named as odd. Beside the odd, of course, you need to have even. After even, it's going to be odd again. And then you're going to have even again. If you have another layer, it is odd. Another layer is going to be even, and etc. But first thing first, from your output is going to be odd. Okay, that is the first thing. And then what else? Okay, from here there will be a question asking you to only replace at the following level. Sometimes they ask you to only change at the odd level. Sometimes they ask you to only change at the odd level. So that's why you need to know whether it is odd or even. Okay, you can try to go through and check each one by one. Here, this is example, but this is on the question. Okay, it asks you to redraw the logic diagram, which is already explained here, but I don't like sentences. That's why we can directly go to example, so it's like much more clear. You can see here, redraw the logic diagram and develop the output expression using dual symbol. See, dual symbol. If you have Nand Gate, how the dual symbol look like? It will be O gate with a negative bubble there. Okay, it asks you to do only for the odd level. So you can see here, starting from near to your output is going to be odd. This one is the even. This will be your odd. So which level you're going to change? This part and this part. You're going to change to be a dual symbol. How your dual symbol look like? So from here, you change to be the O negative, negative O. And this change to be negative O. This change to be the negative O. See? Nothing different. Then you can, like, maybe later on it's ask you to simplify. Okay, if only, okay, if it asks you to simplify, you can see here this and this can be simplified. This and this can be simplified. So you get and get only here. And then connect to your O gate. That is the things. If you have before the output is like not gate, so you can also like simplify also can. You need to know the function of this bubble, okay? But the question didn't ask you on the simplification. That's why the final also can be like this. But if they ask you like a circuit with the simplified version, you can remove this and this. Okay, so there is another question. It asks you redraw the logic which is similar circuit, but this time even level. So start with your output side. This will be odd first, and then this even, this odd. So even only at this side, you change this to be your dual symbol. From here, you change to be your dual symbol. This one change to be a dual symbol. So you will get like this. This can be removed. This can be removed if needed in the question. So this is how it looks like. In terms of expression, I guess all of you already know how to get the expression there. And just now, Nand Gate, the example for NOR gate also similar. You can try to see the bubble cancel the bar, bubble cancel the bar, bubble cancel the bar. So let's go to direct example here. Implement the expression using with no logics using the appropriate dual symbol. So it gives you the NOR gate, but you need to change to use the dual symbol. In this question, it doesn't mention or either odd or even. So that's why you can choose by yourself whether or even. So maybe you choose the odd, you can change the odd only. See here. Or even you can change this part only. So this bubble cancel, this bubble can cancel. So the final you can also get O and also and get O and also and get. Another question, it asks you to, you can see, prove that this circuit equivalent using the Boolean algebra, using the De Morgan theorem also, and De Morgan theorem for the odd level. So this is odd level, this is odd level. What you need to do, you need to change this one to be your dual symbol like this dual symbol, this dual symbol. And from here, you're going to get, this one is what? This is a not. That's why you get A bar, B bar. B not, B bar, see? So from here, you have bar and bar, it cancel each other. So you will get A, B, A bar, B bar at this side plus C. And for this part, it will cancel the bar over here. So you will get A bar, B bar plus C at this side. And you multiply it. This one is already cancelled. Bar and bar, see? Bar and bar. So you have 2 bar. Bar and bar you put here. So it cancel each other. So this one is not, this one is not, this one is not also. This is the no, this is O not. So you know how to do it. And another one is on an even level. So this one is odd, this is even, this is odd. So you change only the even level here. And you get the expression. This one is exercise you can try to do. And now we're going to look into the problem statement. This one is need more on exercise and also your understanding. Sometimes, especially me myself, which is I really had on reading, so it's hard for me to sometimes understand the sentences fully. I need to repeat, read until I fully understand. So at the step number 1, if you don't understand fully, basically all your answer will be wrong. So this is the critical part. Answer, convert, and try this step you need to know. Okay, most critical stage, said step number 1, you need to understand the situation. Example here, you were given with the statement, with the scenario. You need to read and need to carefully understand how many input it have. And then for the input, when it's going to be 1, because you know that if let's say you have the input of A, B, C, when the condition it will be 1, when is the condition will be 0. So you need to know in the statement given. So in this statement, you have 3 input, 3 tank, which is 3 input, and you're going to have high, which is input 1, when your voltage level is low. So when you have like this tank, this tank, this tank, like your motor meter, if your oil or diesel is lower, so you're going to have like red light in, at your motor or car. So similar to this, it is a below, but it is not red. Instead, it's going to be high. See, your input will be 1. For this tank, the tank A, for this tank B, it will be high when it is low. When it is low for this one, tank C is going to be high. Another one, so that is the scenario you can see. Below is going to be output 1. Else or low is going to be 0. So next, it's ask you, you continue reading, you're going to see that your output will be getting 1 when 2 or any 2 of the tanks is below specific point. So you need to monitor. If it's below, then you're going to have the trigger. So you can see produce high, 1 is high, but in the relationship, if 2 tanks, then has a logic 1, the output will be high. Then you need to construct your own table using the scenario given. So you need to construct your own table, then it will be look like this. Maybe you don't see this table, you try to solve this question and come out with your table first. Check your answer, is it correct or not? Then from this truth table, you can simplify using your chem map, and lastly, get the equation for the expression. Okay, so here from the previous example, implement, okay, from this right, you already get your simplification version. You can draw into a real situation like a tank here. And this is your circuit. And from this one, it asks you to change your circuit. This is your circuit. Change and draw using universal gate only. So from here, what you need to do is you're going to put your bubble to be Nand Gate. If you have the SOP, universal gate, what universal gate you will use? Nand Gate. Nand Gate, Nand Gate, and you put bubble here. This one is dual symbol for your Nand Gate. So you change it to be Nand Gate. And after that, draw the final circuit using dual symbol. This soalan lain eh. This one is 5.9. This one, it asks you, you can see similar things, which is if you put bubble, also can get the final version. This is long step. You replace it one by one with the Nand Gate. And if it asks you, because it doesn't mention whether you need to use the Nand or no, you try to draw both. Now you're already done with the Nand Gate. We change this to be this one to be no gate, this one to be no gate, this one to be no, this one to be no. And this is your circuit. From here, there is another question asking you to do a dual symbol only, whether it is, let's say, NAND only or a NOR only. So where you going to change it? Is it there is mentioned whether odd or even? Wait, no. So you can change its any level. In this question, it's changed at the odd level. This one change at the odd level. Odd also. You can see if odd, this odd, this odd. You need to change both. If you want to change even, this side and this side will affect using the dual symbol. There is another example. I want you to try before you start doing your lab 2. If you can do this example, then you can answer your lab 2. The rest is just for you to recap what you have learned throughout your module 5. Any question, you can check this recording class again, and also you can also check the video that I already provided in your e-learning. Any question? If no more question, we can end our
Doctor, I have some questions for the lab exercise.
Okay.
For the question 2 in part 1, do we need to write all 16 possibilities in the truth table?
Yes.
Like A, B? Okay.
In your
And
final exam and your test too, sometimes it's more than 4, sometimes it is 5 input. So you need to construct all the table. Okay, next.
when is the deadline?
I give you 7 days, which is 1 week.
Okay.
Then I will create a submission link below the lab 2 file. So I will create here the submission link. Okay.
For the video, does everyone submit or just one person?
For the video, I suggest you to submit by yourself also individually, because don't depend to others. That is what I learned
Okay.
from your seniors' mistake, because some of you are always depend, because normally I'm going to take like 50% mark for video and 50% for the report. If you didn't submit the video, your friend did not submit your video for you, then you just get half mark. Okay.
So even if all of us have the same video, like can
Yes.
all of us use the same video? Okay.
Supposedly it's going to be same. Just to make you learn from like, yeah, don't depend on others. That is the moral of story. Okay, any other question?
That's all from me. Thank you.
Okay. So if there is no more question, we can end up. But I hope that you can start creating your own WhatsApp group, discuss with your friends to finish your lab 2. Okay. Okay. Thank you all. Stay safe. Bye bye. Thank you, doctor. Okay.
Sorry, doctor. Can you share
Yes.
Thank you,
the
Rada.
Yes, sir.
attendance?
Okay. Can.
Yeah.
Thank you, Doctor.
Thank you, Doctor.
Bye bye. Where's the QR code?
Doctor,
Yes.
our test 2 is on 1st of January, right? If according to CI.
Yes, 1 January.
Okay.
I guess there is no change. Later
Okay,
on,
yeah.
if let's say there is any important news, I will share with all of you. Okay.
Okay, doctor. So the examination hole will be displayed again, right? If we got test 2.
Yes.
Okay, thank you.
Okay. Bye.
Okay, thank you, doctor.
Okay. Thank you.
Thank you, doctor.
Thank you, doctor.
Okay. Thank you.